Hey everybody, these are the trig identities, and basically you are learning to turn one trigonometric expression into something else using reciprocal. You'll use a quotient and you'll use Pythagorean. There are also some situations that you do need to recall from the beginning. There's your angle A. The sine of A was the opposite over the hypotenuse, A over C. The cosine of A was the adjacent over the hypotenuse, B over C, and it was exactly the reverse for B. So, if you remember that A and B are complementary angles, say, their sine of 40 is going to equal the cosine of 50, and vice versa. If they are complementary angles, you normally write it sine of 90 minus x will equal cosine of x. These are called cofunction identities. They come basically from this. The cofunctions, the tan of that 90 minus x is also equal to the cotangent of the x, just like the 40 and the 50 are complementary. And your secant, 90 minus x, is going to equal the cosecant of x. Those are your cofunctions. All right. To remember this, your sine, cosine, and tangent, people use the SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. That probably goes back to middle school, the first time you saw that. These are adding in. These are reciprocals. Your cosecant is 1 over sine, so it flips. Instead of it being the opposite over hypotenuse, it's now the hypotenuse over the opposite. Secant is the reciprocal of the cosecant, so hypotenuse over adjacent. And your cotangent is the reciprocal of your tangent, or adjacent over opposite. So here are the reciprocal identities. There is a page that I have put in the assignment, your notes assignment, that you can download and print out. It's got all the identities that I've mentioned so far on there. You've got your reciprocal identities, you've got your quotient identities, the Pythagorean identities. You also have those cofunction identities that I just did on the slide past. Okay. This also leads to the next identities, because if you cross multiply, went the wrong way, if you cross multiply, sine times cosecant, it'll equal 1. Cosine times secant will equal 1. And tan times cotangent will equal 1. So, you've got those, and that's pretty easy to figure out, because you've got sine times 1 over sine. And the signs would cancel out, which would leave you 1. Okay. We did a unit circle back in Math 3, and you learned that the x value was the cosine of this angle, and the y value was the sine of this angle. So that point was cosine sine. So when you are looking to find what the tangent is, that's the opposite side over the adjacent side, which would give you sine over cosine. That is one of the quotient identities that you get. Sine over cosine. The cotangent, being 1 over tan, means it would flip, cosine over sine. You can also do some maneuvering, or you can just list them down there. Tangent equals secant over cosecant, and cotangent is cosecant over secant. So, all of these, like I said, are written down on that sheet. You'll want to have them there, and you'll want to know which ones to use. When you've got this, remember your Pythagorean theorem. A squared plus b squared equals c squared. In this unit circle, then, sine is A, cosine's B, and c is 1. So you would have sine squared, and this is given in theta, so radians, plus cosine theta equals 1 squared, which is just 1. That is a Pythagorean identity. Oops, and you've got a couple others. 1 plus tangent squared equals secant squared. And 1 plus cotangent theta equals cosecant squared theta. So these are all your Pythagorean identities, which are also listed on the page. So here are the type of problems that you're going to get. Transform sine of x cotangent x to cosine of x. Look where you're starting, sine and cotangent. Look where you're ending, cosine. So, third thing, look at your list of identities. Which one would get a cosine into the beginning expression? Well, if you look at your quotient, your cotangent is cosine over sine. That would put your cosine in there. So sine x times cosine x over sine x. Once again, your sines would cancel out, and it would leave you strictly a cosine of x. Your next one, transform these three into 1. All right, since we're getting 1, then you're going to end up having to cancel a bunch of stuff out here. So, sine is just sine for the most part. Secant is 1 over cosine. And then cotangent is, cosine over sine. Tangent is the sine over cosine. Cotangent is cosine over sine. So, we'll look at what we got to cancel out, and you got a cosine on the bottom and 1 on the top. Sine on the top, 1 on the bottom, and that does in fact leave you 1. Okay? So, the next thing we've got is, whoops, wrong mouse. Transform cosine squared x minus sine squared x into 1 minus 2 sine squared x. When you see the squares, you're going to be using your Pythagorean identities. So, you will always use the identities that will use the trig terms you need in your answer. You're always trying to move things that way. Well, here we've got sine squared x plus cosine squared x equals 1. And if I move the sine squared over, then cosine squared equals 1 minus sine squared x. I can then take that whole thing and put it in here. So I have 1 minus sine squared x minus sine squared x equals 1 minus 2 sine squared x. Because 1 plus 1 is 2. And that's your final answer. So that's the sort of thing that you're working on the whole time. And we've got this right here, tan x plus cotangent x into cosecant or secant. So I was looking at the ones where you have, you're trying to get tan and cotangent into that, and looking at maybe trying to do some secants and cosecants, because that's what I'm going to, but it was a dead end. So I had to start over. Then you try the quotient identities. Tan is sine x over cosine of x. And cotangent is cosine of x plus sine of x. So just like when you're adding, 1/2 and 2/3, you get a common denominator. Well, just like you did 2 times 3 to get 6, you're going to do cosine x and sine x to get your common denominator. Once you've done that, then what do I need to make this look like this? Well, I need another sine x. So sine x times sine x would be sine squared x. And I need another cosine to make this denominator look like this denominator. So I have plus cosine squared x. Sine squared x plus cosine squared x is the 1, like we just did. And because this is multiplied and it got a 1 on top, I can split this up. 1 over cosine x times 1 over sine x, which is going to be 1 over cosine is secant, and 1 over sine is cosecant. So if I flip that around, it's going to be identical to what we have up there. Cosecant x, secant x. And that is all you've got to do on here. Just take one thing and turn it into something else. And that is your trig identities.